Mm, Good morning. So today we are going to talk a little bit about um, graphs of quadratic equations and polynomials. So we are doing quadratic equation, quadratics and polynomials. Polynomials. And then this video is to guide us on some important concepts that are required for your SAT. Okay. So we are not going to focus on some very easy concepts. We are just going to be focusing on very important concepts required for your staff. Okay. So the first thing I'd like to talk about is that when you have a quadratic equation and then you have, the vertex of the parabola. The curve of a quadratic equation is called a parabola. Parabola. Para. Parabola. Okay. So if you have the vertex of parabola to be a comma b, a comma b, then you should know that um the line of symmetry of the parabola, the line of symmetry of the parabola would be to line, then the line of symmetry of this parabola will be equal to, or would be given by x equals what? A. Very simple. So you might be given a question where probably you are just given, let me say, quadratic equation in the standard form, in the vertex form, any form, or probably you can be given the vertex of a parabola directly, and you'll be asked to find the line of symmetry. So the line of symmetry, would be x equals the x coordinate of the vertex. Okay. So if you have a parabola to be this, then this is your line of symmetry. This is what you are saying, that is x equals a. Now you might ask, then what is the relevance of the b here? The b here would be what? Our minimum or maximum value of the parabola. Minimum or maximum value. Minimum or what? Maximum value. Okay. Yes. Minimum maximum value. So I guess now we are clear. So we can now find the line of symmetry of a parabola. We can also find the minimum or maximum value of a parabola. And the next thing I'm going to talk about is some of the things we can deduce from the equation of a parabola. When we are given the equation of parabola in a standard form is ax squared plus bx plus dx plus c dy equals. Now, this provides us with a lot of ideas, or we can deduce a lot of information regarding a parabola from this simple equation. And we call this the standard form. We have the vertex form, which we'll talk about later, and then you also have the factored form. So we have three forms in which you can present the equation of parabola. Now, with this, first thing you should know is that the A here provides us with two key ideas. So it tells us whether the parabola, that's the graph of the parabola, points upwards or downwards. And that subsequently would allow us to know whether the graph has a minimum or maximum value. So whenever A is positive or whenever A is greater than 0, then it means that the curve would point upwards. So when A is greater than 0, then the graph will point upwards. Then when it's less than 0, obviously, we know then the curve will point downwards, okay? Now, subsequently, it means that this curve would have a minimum value, okay? Whereas this will have a maximum value. This will have a maximum value. That makes sense because here you just have what? You have the graph like this and opening upwards. So it means the value down here is constant and it's increasing upwards like this. So it means the value here will be the minimum value and then it has no maximum value. It just increases like that. And then for this one, the maximum value is here and it decreases downwards. So from your A here, you could know whether the graph opens upwards or downwards, and then whether it has a minimum or maximum value. Also from A, you could determine whether the graph is narrower or flatter. Okay, when I say narrower or flatter, this is a narrow graph. This is a narrow graph. This is a flat graph. Okay. It could also tell us whether the graph is how will I even say it? It's taller, that is extended, or it's shorter. So the bigger the value of of A. So as the value of A increases, that's the absolute value. As the absolute value of A increases, the graph becomes narrower and taller. Okay. So let's say you have 4x squared. 4x squared with the others. I don't want to waste time. So let's just focus on here. So provided you have, let's say you have 4x squared. The graph of this 4x squared, let's say the graph of the 4x squared is this. Okay, something like this. Now, if you have to be given another parabola whose equation is, let's say, 6, starts with 6x squared, okay, then you should know that um, you should know that this here, the graph of this here, would be narrower than this. So, if you are to draw the graph of this here, then we would have something like this. I mean, something narrower than that of 4x squared. Okay. So, the last thing we are going to talk about, then we are done with A. Now let's move to C. Now the C here tells us the y-intercept of the parabola. The y-intercept is the value of x, is the value of y for which x is equal to 0. Okay. So when you plug A x0, x0, it is obvious you are left with C. So C here will be our y, what? C will be our y-intercept. Okay? Y-intercept. Okay, we are done. Now you're left with B. You might be asked, what would be the essence of B? B is very special. Now, the B here tells us the slope or the gradient of the graph. Okay, so let's say you have a graph of a curve to be like, of parabola to be like this. And then you have your line of symmetry here, of course. Now the slope, the B tells us the the slope of the graph, okay, of this graph, as it passes through the y-intercept. Now, if this is let's say this is our graph, and this is our x, um, our y-axis. Okay, let's take this as our y-axis, and this as our x-axis. Okay. Now you know this will be our y-intercept because that's where it crosses our y-axis. Okay. And so, if you are asked to find the gradient of the parabola as it crosses your y-intercept, then let's say something like this. Okay. If I have to find the gradient of the curve as it passes through the y-intercept, to me, represented by a tangent passing through the y-intercept. Okay. And that is what our B here tells us. So, the gradient of a parabola, okay, as it passes through the y-intercept given by the coefficient of what? X to B. Now, we know why this is so. When you take a straight line, the gradient is always constant. But for a parabola, the gradient is always changing as we move to different points on the curve. Okay. And the B here tells us the gradient of the curve as it passes through the y-intercept. Now, I would want to introduce another concept. Okay. You can use the same concept to find the equation of the line of symmetry. Sorry. The equation of the tangent line that is drawn at the y-intercept. That is this tangent line I've drawn here. This tangent line. To find the equation of this line, we use the B here that I'm talking about. So the equation of tangent to the y-intercept of this curve now is going to be y equals dx plus c. Okay, this is the new setup. So with all this, you are given a quadratic equation in the standard form, and then you are asked to find the equation of the tangent drawn at the y-intercept of the curve. Now, you just look at the equation in the standard form, and then you take this part of it, and that gives you the equation of what? The tangent to the y-intercept. Very simple. Now, the last thing I'm going to talk about has to do with um, the relevance of the product AB. Okay, the relevance of the product AB. That's coefficient of x and coefficient of x squared. Now, whenever you find the product of AB, you look at the sign, whether it's positive or what or negative, and we use that to determine what we use it to determine. We use it to determine the um, sign of the x coordinates. We use the sign of the x coordinates of the vertex. Okay, x coordinate of the vertex. So, let's say you are given a quadratic equation as let's say um, let's say you are given um, 6x squared 6x squared minus x plus 10 okay, plus 10. Now, and you're asked to, and I must say, the sign of the x coordinate of vertex tells us the position of the graph of your curve on the Cartesian plane. It tells us whether it is to the left or to the right side of your y-axis. So whenever your sign of your x coordinate is negative, it means it's on the left side. If it's positive, it's on the right side. So here, when you find the product of a and b, you have minus 6, which is what's negative. So since it's negative, it means the sign of our x coordinate of the vertex will be positive, okay? And if that's so, then it means that your graph would lie on the right side of your Cartesian plane. So if you have to draw it, you have to draw the graph, and this is our Cartesian plane, then our graph will be somewhere here. Now you might ask, what if the product is 0? Now what that means is that the graph lies directly on the y-axis like this. Okay, like on the y-axis like that. So I think that will be the end of this session. Thank you for your attention.